project lead for the support that CoSeC provides to the HEC. And as such, what I wanted to do today was to take the opportunity, given this is the first of these events for HEC-WSI, to describe CoSeC, because we appreciate that not everybody sort of outside of these communities is necessarily aware of what CoSeC is, and what it does and what it's for. And also then just to give an overview of the HPC landscape that I think the UK is currently operating in. And the primary purpose of that is to describe the importance really of what the HEC is doing, and hopefully to show how all of this is interlinked in terms of UK science. And then I'm going to give a high-level overview of the work that the team from CoSeC are involved in within the specific work plans of the HEC itself, but also just to give an idea really of what we can do, because obviously we work within a work plan that we defined when the HEC was funded, but ultimately we're there to provide support to the community. And so if that work expands, changes, evolves, then we're able to do that as well. Okay, so the first thing I wanted to do is just to describe STFC, and I started doing this recently because it struck me that I was talking about STFC, I was talking about all of these sort of elements of things that come together to form the UK's digital research infrastructure. And not everybody's well aware of kind of how all the UKRI landscape currently looks. So STFC is fundamentally part of government, and it's funded directly through the Department for Science, Innovation and Technology, which was formed from the department formerly known as BASE. And DSIT, as it's referred to, directly refunds UKRI, so UK Research and Innovation, and there are 9 councils within UKRI, and STFC, as you can see, is one of those 9 councils. So I'm not going to go into any more detail than that, but it's just sometimes useful, I think, to remember the landscape that we're kind of operating in the UK. And you can see EPSRC there, which is perhaps one of the more important councils in relation to the high-end consortium. So the next thing I wanted to do was to describe what these things are. What are high-end computing consortia? And so the HECs are 4-year EPSRC funded projects, and they provide members and users, as we've seen, with access to computing resources, typically on the national HPC services. So in the current situation, that's Archer 2. But the actual concept of the HECs can be traced back for quite a long time, actually, back to the early 1990s. And they came out of a wider computational concept called the Collaborative Computational Project concept, which in turn can be traced all the way back to the 1970s. And basically the CCPs sort of made it evident that there was a need for there to be organized activities around the use of national supercomputing facilities. And that came to a head in the early 1990s where the HEC concept was formed. And it's kind of gone from strength to strength from there, really. So currently there are 6 HECs around different areas of science. And the HECs are supported not only by EPCC in the case of Archer 2's access, but STFC's Computational Science Centre for Research Communities, or CoSeC. So what is CoSeC? So it's a cross-council funded programme, and it's run by STFC's Scientific Computing Department. Primarily, it aims to work with council-funded collaborative consortia. So the HECs, obviously, are the example we're using here, but there's also the collaborative computational projects as well, and there's quite a few of those. And it works on aspects of computational science, so looking at things like software development, scientific software development, support, maintenance, collaborative and fundamental research, training and outreach, so with training actually being a very important aspect, and development of methods and techniques, so some fundamental work there as well. In terms of the areas of science that CoSeC works in, so CoSeC itself is quite a large program. It represents about 60 STFC computational scientists, research software engineers, and support staff. But support for the CCPs and the high-end consortia is kind of the core tenet, and really the science that CoSeC does is shaped by that support. So while the scientists that work within it obviously have domain-specific expertise in their various areas, the overall landscape of CoSeC really is shaped and defined by the CCPs and the HEC, the EPSRC, and the other councils currently fund. So the current landscape is, as you can see on this slide, and you can see that at the moment there are 4 key areas. So computational engineering, biological science, tomographic imaging, and material science. And then there's a cross-cutting theme around quantum computing. But this landscape does change. It doesn't change radically, partly because of the length of the CCP project at 5 years and the HECs at 4 years. But it does change. Recently, the plasma physics element of the landscape that CoSeC supports has kind of disappeared, and that's just the nature of how this process works. And undoubtedly, it will come back again at some point in the future. Okay, so the next section is, I should add a caveat before I do, sort of my derived opinion of the UK HPC landscape. I've hopefully been as factual as I can be, but the reason for doing this section was I hoped it would be useful to provide some sort of context, really, as to where we're going in the UK in terms of HPC. And on the back of that, hopefully it will be obvious why the HECs are so important and why the work of the HEC is so important. So I apologize for anybody on this call who sort of already knows all of this, but sometimes it's useful just to lay down sort of a base layer to make sure everybody's on the same page. So to date, high performance computing, or supercomputing as the rest of the world calls it, in the UK has been driven by individual councils. So EPSRC, NERC and STFC are probably 3 key ones amongst them, but there are activities across some of the other councils as well. So some of the systems that probably you're aware of, so Archer 2 is the obvious one, but then there's another system called DIRAC, which is funded by STFC. You've got clusters like the BEAD cluster, part of the N8 consortium, Cirrus, which Sebastian mentioned earlier, and many others. There are lots of these sort of systems around the country. It's quite a good resource there at HPC-UK, ac.uk, to just have a look at them and to see sort of where they're based, what they do, and how to access them. But fundamentally, these are split into 3 tiers. So we often talk about tiering when we talk about HPC systems. So we might talk about tier 1, tier 2, tier 3, but fundamentally what that means is tier 1 are the national systems. So Arch 2, DIRAC is another example of a national system. And then we have the HPC center system, so the likes of Cirrus, BEAD. Often these are located in various different places. So Cirrus, for example, is hosted by EPCC. And then the local clusters. So these are the tier 3 ones. And really, this is your favorite local cluster. So often there's lots of these scattered around the UK's universities. But fundamentally, this is how we tend to view the HPC landscape in the UK currently. So the creation of UKRI in 2018, so it was 5 years ago now, offered the chance for a new approach. And so the UKRI-wide Digital Research Infrastructure, or DRI strategy, was created. If you're not aware of this strategy, there is a link there, and I'm sure we'll disseminate the slides afterwards, but obviously you can find it just by Googling it. But this is now relatively well established as an idea. So this is the driving force behind the HPC landscape of the UK at this point. And there are some potential upsides to this idea of looking at national computing infrastructure from a truly national level. And one of the main ones is it offers the potential for larger pots of money than we're used to create internationally significant HPC resource. I'll go into a bit more detail about what I mean by that in a few slides, but it also offers the opportunity for enhanced collaboration to find more widely applicable approaches. So by that, I mean, rather than EPSRC producing something for EPSRC's community, which may also then happen to be useful for NERC's community, we can consider the needs of the communities across the whole of UKRI's remit. The potential downsides are a lot of domain-specific optimization. So often doing something which is universally useful means losing focus, and that's just true of almost everything, and that's true here as well. So that's a potential downside, and it could lead to a reduction in scope and the variety of national infrastructure if council-led efforts reduce as a result. So this really is a big if, and I really should caveat that this really is my own personal view. But if the national take on digital research and on HPC becomes more national, and you lose this sort of council-led approach that has led to the likes of Arch 2, as we currently have, then that could reduce the scope and variety. And that's not to say that's what will happen, but it's a possibility. So the reality of where things are is still unfolding. So this slide really is just intended as a whistle-stop tour of the current state of affairs. So if you weren't aware, recently a £900 million investment into new national AI computing and exascale computing was announced by the Chancellor, and that was announced early this year in the spring budget. And unusually for the UK, everything has moved incredibly fast from that announcement. So part of the AI resource that was announced within this pot of money has also been announced recently. So this is the Isambard AI service, and this is going to be hosted by Bristol University at the National Composites Centre. And this will be available soon as a national service, a national platform with sort of announcements expected imminently as to what it's going to look like specifically, how you'll be able to access it, and all those sorts of things. So this really is moving quite fast. And it's also been announced that the Edinburgh Parallel Computing Centre, or EPCC, who host Arch 2, will also host a new exascale system as part of this, with work starting around 2025, and obviously details of that will unfold over the coming years. So the key questions are, and these are the things that I think a community like HEC-WSI should bear in mind, is the UK now creating a new tier 0 for national DRI HPC infrastructure? And what happens to the current tier 1s? So for example, Arch 2, does this become the new exascale system, or will EPCC host both? And what will the Isambard AI and exascale systems look like in terms of architecture? And perhaps that's the bit I'm going to explore a bit more, because I think it has some real technical importance for the work that we do and the way that we consider use of HPC. So exascale, I suspect most on this call will have heard of the term and will know what it means, but it's also one of those terms that's being used a lot at the moment, and so it seems sensible just to define what I mean by that and what that looks like at the moment around the world. So simply put, it's a single computer, supercomputer, capable of calculating 10 to the power of 18 floating point operations per second. And to put that into context, that's around 40 times the capacity of Arch 2. So according to the official top 500 list in the world, there is officially currently one of these, and that's Frontier at Oak Ridge National Lab in the US. However, others are very likely to exist across China. And the EU has recently announced its own Jupiter system, and that's part of the Euro HPC program. That will be at the Jülich Supercomputing Center in Germany. And Japan is also working on its next big system. So Japan has the current number 2 system, Fugaku, and they're currently working on their next big system, Fugaku Next, which is very likely to be an exascale system as well. So what we can take away from the way the landscape looks is that all exascale systems so far, so Frontier and those announced, have been heterogeneous in their design. So that's a mixture of CPUs and accelerators, and currently that means CPUs and GPUs. I see no reason to expect the UK system to be different. Obviously, I can't genuinely talk about what that means because I don't know. However, it's very, very unlikely that the UK system will be anything other than a heterogeneous approach. And this really is fundamental to HPC communities like HEC-WSI. So this is something that we now need to take forward as an idea. And so, the key takeaway is the future of HPC is not homogeneous. So it's not homogeneous like Arch 2 is. It's a heterogeneous system. And that's where you have to make efficient use of huge numbers of different types of interconnected processes. And I think that that really is key for how we view the future of HPC, but also how we view the use of the current HPC that we have, like Archer 2. So what's the path to exascale for the UK and beyond? So actually, at the moment, there is an ongoing program called the Excalibur program. This is a software development program, in fact. It's a 5-year program into its final few years with a worth of about 50 million. It's not insignificant. On the world stage, still a relatively small investment, it would be fair to say, but not insignificant, and certainly not insignificant in UK terms. There's been some very significant investment into existing UK HPC. So, for example, the Dirac service has recently announced some significant upgrades. Other centres, like the Hartree Centre within STFC, currently tendering for their own quite significant system. And then, of course, we have the very large announcements that are leading to the Isambard AI service and also the Exascale service at EPCC in the future. But also long-term investment into the high-end computing consortia. So these HECs, as I said, have been around since the early 1990s. So this is a long-term strategy on the part of EPSRC. And the programs like CoSeC that support the HECs and the CCPs are a long-term sort of part of the DRI strategy that's then leading into the UKRI DRI strategy going forward. So there's also been some very interesting investments made through the Euro HPC program in the EU and the Horizon funding programs. So, for example, the Exaphone project is a key project at the moment, which is an ongoing Horizon 2020 funded project, looking at taking OpenFOAM to exascale sort of proportions, and they've recently started to publish some really interesting stuff looking at the very significant scalability that they've been able to achieve using some nice developments to the OpenFOAM stack. So I think really the really important thing is exascale is a reality. This isn't now something we're talking about sort of in the future. It exists now in a sort of a small way in one part of the available kind of computing infrastructure certainly in the West, but it will exist in the UK within the next 2 to 4 years. Before that, use of HPC far larger than Archer 2 is likely to be available as well. So communities like this, like HEC-WSI, now need to leverage Archer 2. So that doesn't mean running on a node. It means trying to run on lots of Archer 2's nodes. So we saw the scale of Archer 2 at 750,000 plus individual cores. The Exaphone project is showing that, so they've recently run a scaling study taking an OpenFOAM solver to about 500,000 cores. And so these things are now tangible. And so this community really can push these things forward, leading to the sorts of scalable solutions that can be used on these exascale systems in the future. Okay, so the next thing I wanted to do then was to provide a high-level overview of the HEC-WSI CoSeC Workplan, and also just to give some context as to how CoSeC works with this community and the sorts of things that we're able to do. So fundamentally, I mean, I've already described the basic idea of CoSeC and what it does for communities, but fundamentally for HEC-WSI, CoSeC is providing computational science support, and that's to the entire community. So although we work very closely with the immediate working group of HEC-WSI, obviously there's a number of people on this call perhaps who aren't part of that conversation, but are part of the community. So the purpose and the point of the CoSeC support is that we can extend outward into the community, and indeed that's exactly what we want to do. So we want to work on areas like scientific software development, algorithmic development, HPC application performance engineering, and delivering useful training as well. And that's not necessarily just around the use of software or the use of a platform. It might be training around a method, for example. So we have a wide range of skills and availability to provide support to the community. We're also helping to enable computational infrastructure, so websites, data collation. So the CCP-WSI that sort of underpins HEC-WSI has a very strong data cataloging exercise currently going on, and so the CoSeC support for the HEC, obviously we'll take that forward and expand it into the HEC's remit as and where that's appropriate. And then undertaking a specific work plan within the project itself. So the work plan, I think the very first thing that's sort of worth saying is that the purpose of the CoSeC support for any HEC or CCP is that the work we do within the sort of defined plans is flexible, and that's absolutely imperative. If you have a 5 or 4 year project that's aiming to support the community that's evolving by its very definition, this HEC-WSI is a starting point for the waste structure interaction community to really start to understand how to make use of HPC resource. And so the expectation is the work that goes on within the community will expand and will evolve. And so our plans are and have to be flexible. So our plans are a starting point, but they can and they should, in my opinion, change according to the needs of the community. So the key work packages, so Deborah touched on these at the start, but I just want to sort of go into a bit more detail as to what this actually means in reality. So the first work package is around porting, optimization, and code development for wave structure interaction. And I think this is probably the most key one for the support that CoSeC is providing directly to the work that's being sort of driven by the working group. So what we're doing is looking at key codes. So codes like OpenFOAM, Paraffin, which is a parallelized finite element code of quite great importance to some of the working group. Phoenix, so for anybody who's aware of the Phoenix package, it's a general purpose finite element code that has great applicability, not just to structural mechanics, but to lots of, basically any solution where you need to use the finite element method. And then performing WSI specific profiling on Archer 2. So what do I mean by WSI specific? Well, if we take OpenFOAM as an example, when we actually look at the use of OpenFOAM by the WSI community, OpenFOAM is a huge code base with lots of capability and lots of solvers even by default. So you download OpenFOAM and that gives you access to maybe 30 plus solvers, all with different physical capability. But when it comes to wave structure interaction and the community, I think we're able to start to say that actually most of the work, the useful work that goes on, involves the interFOAM solver. So things like capturing floating offshore wind turbines, you need access to the multi-phase free surface capability of the volume of fluid method. You need access probably to the ability to do 6 degree of freedom rigid body floating dynamics. So all of these things are in the interFOAM solver. So when we talk about OpenFOAM in WSI specific terms, we can start to narrow it down. So that's what we're really doing. We're starting to look at the subset of OpenFOAM that's important to the WSI community, and then looking at what that means on Archer 2. So when you use interFOAM, the scalability and the HPC capability of the code has a baseline, and that comes from the OpenFOAM code base. But when you start to introduce all of the extra complexities and its multi-physics capability, actually there are aspects. So for example, the 6 degree of freedom rigid body dynamics capability, which really have an impact on the way the code scales and performs in HPC terms. We're also looking at the potential for developments in terms of GPU acceleration. So hopefully I've already set the scene as to why I think GPUs and looking at heterogeneous computing is so important. But then projects like ExaFoam have also picked up on that and made that important. So we're taking the work that projects like ExaFoam are doing, we're considering it, we're disseminating it as best as we can, but also looking at where we can sort of do things ourselves within the OpenFOAM code base, and then sharing best practice and directly optimizing WSI community code. So sharing of best practice is something that really is quite important probably. So in terms of the scientific use case development and sharing then, so this is the next work package where CoSeC has some involvement. So primarily this involves working directly with a dedicated RSE, Plymouth University, funded through the HEC, and helping to develop use cases to demonstrate the HPC need, but also the capability of specific WSI cases. And finally, training and dissemination. So this basically means development and support of infrastructure to help distribute access to Archer 2. So the website, helping with the calls, helping to make sure all of that runs smoothly technically, but also providing training around topics like code development and HPC use. And actually a really useful thing for us would be to get some feedback from the community, perhaps through this event or perhaps after this event or through other events like this, as to where the training needs really are. So this is where we can potentially go beyond the training that the Archer 2 platform can provide. So that can provide, EPCC can provide generic training for access to their system for specific areas around, for example, MPI parallelization of codes, those sorts of things. We can go deeper into the specific science. We can go deeper into the specific use of open foam for WSI specific cases. That's within our remit. But we need a bit of drive and we need a bit of a steer as to what the community really is interested in next time. Okay, so very quickly then, as a conclusion, so CoSeC is a long-standing program run by STFC. It's gone through a number of name changes, but it's a very long-standing activity, and it's designed to provide computational science support to communities like the CCPs and the HECs. And fundamentally, HECs like this one are here to enable the use of national computing resources like Archer 2. The nature of HPC in the UK really is changing, both in terms of scope and scale. The scale of what comes in the next couple of years really is such a big step change. The future of HPC is heterogeneous. I don't think I'm going to look back and say, I wish I hadn't said that. I think it's just true. Large scale parallelism, large numbers of CPUs connected to hugely powerful CPUs. So CoSeC works directly within HEC-WSI and is available to provide computational science support to its communities, as well as undertaking a specific plan within the project. And with that, I'm finished, and I'll just take the opportunity to advertise the fact that there is a CoSeC conference. We're running an annual conference series. This is part of a wider conference called the Computing Insight UK event, which happens in Manchester in early December. There is currently a call open and registration is also open. And so I encourage you to come along if you're interested and excited by any of this. Thank you very much.
Okay, thanks very much, Stephen. And that was really, really helpful to give some real insight into the strategy for HPC and DRI across the UK. Right, so thank you very much for that.